Dear colleagues, my name is Ronald Tello, and I have the pleasure to present my work entitled Preparation of Ternary Composite Using Biopolymers, Activated Core Pith, and Iron Chloride Hexahydrate for the removal of anionic and cationic dyes in aqueous solutions. I am an environmental engineer. I'm a research assistant in the Biomaterials and Polymer Research Group at National University of Engineering in Lima, Peru. I'm focused on the exploitation of our industrial waste, in this case, coconut, Cocos nocifera, to do composite with polysaccharides in order to propose an eco-friendly alternative to the contaminated wastewater from textile industries. To begin with, according to Sharma et al. 2021, over the years, textile dyeing technology has transformed the developing industry since the discovery of the first synthetic dye, Movin, by William Henry Perkin, 1856. Currently, more than 700,000 metric tons of synthetic dyes are produced annually in the form of 10,000 structurally in different colors. As you know, the textile industry processes are causing detrimental effect on environment due to the presence of anionic and cationic dyes in wastewater streams that heavily pollute aquatic ecosystems. Moreover, the existence of dyes in the aquatic environment causes a decrease in the penetration of sunlight into the water. Therefore, photosynthesis activities are decreased, as well as the content of dissolved oxygen is reduced. Indeed, exposure to the dye through ingestion can cause harmful health effects in humans. Furthermore, dyes are carcinogenic and mutagenic. They can cause kidney, bladder, and liver cancer. This issue represents a serious problem taking into account that commercially available absorbents are usually very expensive for their application on a large scale. Among agricultural residues, the use of coconut residue as an absorbent has gained ground for this ability to remove heavy metal from wastewater. Likewise, several researchers consider that coconut waste could be a promising precursor for the absorption removal of dyes from wastewater. As you can realize, we chose for the coconut specifically for the core pith. This is a crusher and little study waste. For this reason, the utilization of low-cost materials such as core pith and biopolymers could be an option for preparing binary composites. Hence, in this work, the core pith was activated using sodium hydroxide, hydrochloric acid, and sodium chloride for the preparation of a ternary composite using biopolymers as a matrix like pectin, alginate, and carboxymethyl cellulose, and iron chloride hexahydrate. Therefore, the objective of the application of ternary composite is to determine the removal efficiency of anionic and cationic dyes in aqueous solutions. In image A, it can be seen that 5 grams of core pith are added in 200 milliliters of 0.1 molar sodium hydroxide, sodium chloride, and hydrochloric acid, and keep stirring for 6 hours in a magnetic stirrer. After that, it is filtered through a strainer and the solid substance is put into petri dishes. It was left for 24 hours at 80 degrees Celsius in a heater. Finally, it would crash and store in airtight glass jars. Now, as you can see in image B, 0.19 gram of activated core pith was added in a beaker with 1.5% pectin. Then the process repeats with 0.25 gram of activated core pith in a beaker with alginate 2%, and the last one, 0.125 gram of activated core pith was added in other beaker with CMC 1%, but this one at 60 degrees Celsius. These experiments were shaken for 3 hours with 750 revolutions per minute. After that, 1.5% iron chloride hexahydrate solution was prepared. It was stirred for 30 minutes. Then the activated core pith solution with the biopolymers is added. It was kept stirring at room temperature. Finally, it was filtered through a strain and the solid substance was placed in Petri dishes. It was left for 12 hours at 80 degrees Celsius in the stove. Consequently, it was crushed and stored in airtight glass jars. As a result, 9 types of composites are obtained based on activated core pith with sodium hydroxide, sodium chloride, and hydrochloric acid, biopolymers, and iron chloride hexahydrate. The experiment consisted in preparing the stock solution of 10 ppm for each colorant, and in 10 test tubes, 50 milliliters of middle orange dye and 25 milligrams of each composite were added. The last test tube is for the control. All tubes were incubated for 24 hours, 100 revolutions per minute at 30 degrees Celsius in a shaker. After that, the maximum wavelength for the dye is identified in an ultraviolet visible spectrophotometer. Finally, the quantification was done. This process was repeated for each dye. As you can see in the bar chart, we can observe that in the case of the middle orange dye, a removal of 25.3% and an amount of absorbed mass of 5.00 milligram per gram of pectin activated core pith with hydrochloric acid and iron chloride hexahydrate composite were determined. The next one, in the case of phenol red dye, showed a removal of 95.4% and amount of absorbed mass of 17.6 milligram per gram of pectin activated core pith with sodium hydroxide and iron chloride hexahydrate composite. Below this, in the case of crystal violet dye, showed a removal of 54.05% and an amount of absorbed mass of 11.23 milligrams per gram of CMC activated core pith with sodium chloride and iron chloride hexahydrate composite. Finally, in the green dye experiment, a removal of 93.11% and an amount of absorbed mass of 23.8 milligram per gram of pectin activated core pith with sodium chloride and iron chloride composite were determined. As a way of discussion, we decided to show these figures in order to observe the removal of the dyes by the composites according to the previous bar graph. In the first one, we can see absorption of middle orange using pectin activated core pith, iron chloride, hexahydrate, and control. The next one, absorption of phenol red using pectin activated core pith, iron chloride, hexahydrate, and control. The next one, absorption of crystal violet using CMC activated core pith and iron chloride, hexahydrate, and control. We cannot see the difference here, but in the last one, we have the control and absorption of brilliant green using pectin activated core pith and iron chloride hexahydrate. And we can notice a real difference here. However, for future research that implies the use of core pith, it could be placed on investigating other concentration of reagents to further improve the performance of these composites. In conclusion, this work has demonstrated the possibility of using a ternary core piece-based composite as a promising alternative for the removal of cationic and anionic ties. In this way, with the free availability of core piece as raw material, the process will tend to be economical in order to achieve sustainable development goals as highly promoted by the new tendencies of circular economy. Finally, our group is really thankful to the Research Management Office of the National University of Engineering and ProCiencia for the financial support of this project. Moreover, all authors expressed their gratitude to the 2022 Global Conference on Polymers, Plastics, and Composites organized by Innovinc International in Budapest, Hungary. If there is any question, I would be happy to answer your question for email or in the next few minutes. Thanks, everyone.